Wait, am I live? Yes, I'm live, and the screen is stuck, which is horrible. And I can hear the music. Oppenheimer. I guess you guys can also hear the music. Let me just fix this and we will begin. Yep, this much voice is fine, I suppose. Yep. And today the camera is horribly bad due to some reason. Oppenheimer. Yep. And here we will just begin. Yes, and cd http server /server, and in postman, if I were to send a request on the server like that without any key or any value, anything, I do get something. And here it says 404. It is right here. I can manipulate the response that I'm sending, which is crazy. Server.c, and for the response that I'm sending is right here. Where is the header? Yep, it is this. So in response, there is a, what is this called? A request header or request line, which has three parts. Wait. This is a response. So this is response header, and the first line in the response header has three parts. First states the HTTP version, and second the status code, and third is optional. It says what the message should be that explains the status code, and then two lines about content or some key value pair. It's like here this is the key and this is the value, and here content length, and then of course comes the content length, and then I can add the body. And every line ends with /r/n. /r is like it means something, and /n just new line. And body begins with a pair of these. One is /r/n, then another is /r/n, and that is just how it is. And for today, my goal is to just first of all make this thing a little clearer. Um, After getting a request here, I want to create a function that would just give me a string which contains all of these things, which I can send out as a request here, as a response to it back. So I want all of this stuff to be in a function. This will return a char pointer using malloc, and this will return a char pointer, and it will be called get response, and it might take something, but for now don't take anything. And start body, stir body, it is a string body, but a string body I have already copied, so this will go in here at the last 14 line, and this also will come here, and in the end I will just return response and semicolon, and indentation seems to be a bit wrong. Now it is fine, and then here just paste it. Yep, function declaration, and here to get a response I'll just call that function char pointer response equals get a response, and here we go, and this should work. Clang serve it with JSON and server /server, and does it work? Let me bring Postman closer. And also, I like this here. And send, and that does work. Server.c. Now, so now that I have made it a little cleaner, how would I want? What other things would I want? What is happening in my while loop? Let me go through this again. Here I am initializing two descriptors, one for the server and one for the client, and then I'm initializing two addresses, one which represents address for server, one for the client, and then socket length. I am taking in the length for the client, which will be used to get the address details for the client when a socket connection is initialized with the client. And then here I have server FT. Yes, here I am initializing a server and getting a file descriptor for that server. FD means file descriptor. That makes sense. FD might mean file descriptor. If it is -1, then that is error. And after that, I'm adding options to the server address, right? And then I'm binding it. Then I'm listening on the server. Then I print that I'm listening on the server. And then if I see any connection request, and this is working on the application layer above TCP. So here, all of this is working on the TCP layer, the application level layer. So here I will see that if there is any TCP incoming connection on the server FT, then return the socket file descriptor that is initialized, and also store the address details in client address, and this is the length for that thing, and a pointer to the length, which is crazy. And then then I print connection requested, then I connection accepted, then I do dynamic rec v, and I print out the response. I print out the response, and after that I print out the request, and after that I get the response using this function which I just created, and then I send it. Where do I send it? I send it to the through the socket which is defined by the client file descriptor. And what am I sending? I am sending the response. What is the length for the response? This is the length of the response, and 0 means something. And then I send it, and then I am printing f \a, which just creates a ping sound whenever I send a response. And after that, a response sent successfully, I close that client and I loop back in the while loop. Now what I want to do is to have multiple clients at the same time, which would mean whenever I see an incoming connection, I will pass it on to a thread and create multiple threads. And how will I decide when the connections are closed? That is a thing. How will I decide that a connection has closed? Okay, we will see. We will look into that. First of all, I have to see how to work with threads. I guess the sound is not too high for you guys, and it's fine for me, just fine for me. Threads in C. Multi-threading, shit, 2 hour. C threads in C are pain. That is not where I should begin. Is in their POSIX post expression. Multi-threading using in C. Threading is a function, so Should I be able to do this? Man thread extension for script access to TCL threading. Yeah. Um, Geeks for geeks. No. Okay. Whatever. Geeks for geeks. And here, what is thread? A thread is a single sequence stream within a process. Single sequence stream within a process because threads have some of the properties of processes. They are sometimes called lightweight processes. What are the difference between thread and processes? Threads are not independent from each other, unlike processes. That makes sense. As a result, threads share with other threads their code, section data, section and OS resources like open files and signals. But processes, thread has, but like processes, a thread has its own program counter, a register set, and a stack space. Why multi-threading? Threads are a popular way to improve application through parallelism. For example, in a browser, multiple tabs can be different threads. MS Word uses multiple threads, one thread to format the text and the other thread to process input, etc. Threads operate faster than processes due to because they do not initialize their own resources but are sharing from a common pool of resources. Thread creation is much faster. Okay, context switching between thread is much faster. uh, Threads can be terminated easily. Communication between threads is faster. uh, Faster. uh, can we write multiple threads in C? Unlike Java, multi-threading is not supported by the language standard. POSIX threads or pthreads is a POSIX standard for threads. Implementation of pthreads is available with GCC compiler, a simple C program to demonstrate use of pthreads basis functions. Okay. Um, pthreads, POSIX thread. Unlike Java, multi-threading is not supported by the language standard. POSIX is a POSIX standards. POSIX threads is a POSIX standard for threads. Implementation of pthreads is available with GCC compiler. Please note the following code may only with the C compiler with pthread library. Okay. Okay. Threads. Okay, first, let's get a conceptual understanding of what threads are. Threads in uh, computing mean a branch that can be created by a running program that has its own program counter and registers to work with, but can share resources with the overall running program, but can share resources with the overall running program. But can share resources with the overall running program. And yeah, yeah. Okay. They run in the context of the program that created them, but can, after their implementation, diverge from their parent context and then at some point in the parent process they can be terminated. executed whenever required. I guess that makes a bit of sense. You're mostly correct, but let's refine it a bit for clarity and accuracy. Vagueness will kill you. Definition of threads in computing. A thread is a lightweight unit of execution within a process. It has its own program, PC, registers, and a stack, but shares the heap, global variables, and other resources with other threads of the same process. Key properties belonging to a process. Threads exist within the context of a process and cannot exist independently. Multiple threads within a process address space, share the same address space, which means that if there are variables and stuff in that address space, the multiple threads within the same process can access those variables, meaning they can access the same variables and memory. Separate execution context. Each thread maintains its own program counter, register, stacks, allowing it to execute independently. Concurrency and parallelism. Threads enable concurrent execution within a program. On multi-core CPUs, multiple threads can run in parallel. They can run in parallel when using different CPUs, or they can run on a single core using time sharing, right? So that it appears as if there are multiple cores, but actually the the kernel is switching between programs and threads to give time to each one of them. Thread lifecycle. A thread is created by a parent thread or main process. A thread can be created within a thread. Amazing. It turtles all the way down. It can execute independently, but remains part of the process. The parent process or OS can terminate the thread whenever needed. Synchronization required. Since threads share resources, synchronization mechanisms like locks or semaphores are needed to prevent race conditions. Okay, connection in your description, correction in my description. Instead of saying thread can diverge from its parent context, it is better to say it executes independently but it still belongs to the same process. Instead of saying at some point in the parent process they can be terminated whenever required, it is more precise to say that threads can be terminated explicitly by the parent or exit their own after completing it. Okay, how to create threads in C. In C, you can create threads using POSIX thread library. POSIX threads, pthread library. Here is a simple execution demonstration how to see how to create threads. It is part of the standard library since it is here. Well, no, it is not. It does not have ST, but it comes with the program, so that is good. I can put Postman to the side for a bit and focus here. Threads. I'm working with threads now, which is cool. Back lscd things made threads cd threads lsn yeah, threads.c, and let's see, include the pthread library. Then this returns a void pointer print message. It takes in a void pointer to something called args, and then printf hello from thread, which prints a long digit. What is the long digit? The long digit is argv. With argv is a pointer. Argv is a void pointer, so I'm printing the pointer which was provided to it, and then return null. Now, main function, I create two threads. pthread t1 and 2 create two threads. Pthread create. Okay, here I'm not creating threads, I am just establishing a variable which can be used to access and do stuff with the thread. And in this part, I am creating a thread, creating, and for this one, I am giving the address for pthread1, right? Pointer, null, which must mean something, then a function which will be executed, and a void pointer. A void, I'm converting one into a void pointer. Okay, whatever I provide here will be given to this function as input, and whatever I provide, I have to provide it as a void pointer. Okay, so I can do this and print here the pointer itself by converting it into a digit, or I can actually store something at that pointer, but that would not be good because it is a void pointer. How would it store something? Okay, we can see that. So here I have created two threads, and then I do pthread join null. So does it mean when this thread returns this, that is it has ended, then join it here, or maybe null here instead of null. Ideally, there should be address for something which will store the return value from this thread. Maybe, I don't know. And then threads finish. All right, let's do that. Um, include stdio and include p thread h in main and p thread t. Yep, thread 1 or thread 2, and then function which they will take in. It will return a void pointer. It will be called thread function, and it will take in a void pointer called argv. Argv sounds good, and inside it will print def. This is a message from inside the thread, and %dl digit ld, and then of course new line. And what is the thing? Convert the argv pointer into this, and then return null. I have initialized the threads, but I have not created. Create. Okay. So first, that is a lot of arguments. That is a lot of arguments. First one has to be address to a thread. So I will give the address for thread 1. Second is a constant pthread pointer nullable. So I don't know, I guess it has to be null due to some reason. And shit, it is actually pretty long. df yes, and given null, and then restrict nullable. What were the arguments? Then print a message, then the arguments that I am supposed to give it. Thread function and the arguments that I am supposed to give it. Void pointer, convert 1 to void pointer, and then pthread create. If this much is the first argument, it will take in thread pointer to thread 2, and wait. Okay, it is still this nullable. That makes sense. And here it will take null as a second, and then void pointer called nullable, and it will take the thread function, and then this will take a void pointer to 2, right? And at this point threads have been created, and then I will close them. Close or join p thread join. Yep, p thread join. Join, it takes in thread a thread which okay, thread 1, join thread 1, and give it null. Okay, pointer. Okay, the thread 1 itself, not a pointer to it. And then p thread join thread 2 null, and then let's just say printf threads joined success double c double s successfully, new line, and yep, that should be it. Clang threads output out / out. Okay, so the threads are working, threads.c, but I do not understand what the heck is happening. I have some conceptual understanding of this thing, but what is happening in the functions themselves? Man p thread pthread POSIX thread functions. What is POSIX thread function? Explanation: pthread create starts a new thread. The thread function print message receives a void argument. Pthread join makes the main thread wait for the created threads to finish. Alright, so at this point, the main function will wait for the thread to stop, and when it stops execution, it will move on further. And passing structures to threads. That is great, amazing. And there is a structure, right? And print info takes in arguments and converts the arg into thread data pointer. All right, and then thread data pointer is data, and printf this and this. Okay, that makes sense. And how am I going to give it to the thread? By converting the data into a void pointer and giving it to the thread, then joining it. All right, key points: passing complex data structures to a thread. The thread function typecasts void pointers back to the original struct, creating multiple threads in a loop. That is amazing. That is something that I want to do. Right. Okay, I have to specify how many threads that I am going to create. Yes, that I can do with the array number of threads, 5. That is the maximum number of threads. Then malloc integer pointers for size of args. What is args? What is pointer args? Allocate memory for to avoid race conditions. Allocate memory to avoid race conditions. I do not understand what are race conditions. Here I am getting void pointer for the size of pointer of pointer to arg. Po no, this means go to arg, and whatever is there, get the size of it, which is an integer. So I guess this could have been replaced by int. I'm therefore getting an integer in argv and then making integer that thing equal to I. whatever is at that location whose address is in this. Right, and malloc returns me memory location in void. So I'm storing a memory address in argv, and at that address I put I, and then I do create thread whose address I'm giving the address for ith thread null worker is this, which does something, and arg. Why have I provided arg just as it is? Because arg is a void pointer. Arg is a void pointer because arg is a void pointer, I suppose. And inside this, I am converting that into an integer pointer and then going to that integer and getting the integer, and then I'm printing the integer. Then I free arg, which is a void pointer in the start, and then I return. Then I start the loop again and wait for every thread to join back, and all threads finished. Why use malloc? Yep. If we pass and I directly, its value may change before the thread reads it. Yes, its value may change before the thread reads it. So that is why we are getting a memory location which will be used to store it, to store the new value, and to store the current value of I into the heap, and it will be there. No one is messing up with it. It is only being freed in within the thread. That makes sense. Using mutex for synchronization. Increment counter, this takes an avoid pointer, and mutex pthread mutex t lock. I have initialized a variable called lock, and mutex lock the critical section counter plus plus counter plus plus, and pthread percent dl long increment counter to this. Right, print first of all the whatever argument I got, and then print the counter, and then pthread multix unlock, and then return. So I lock this at this point, then I do two things, and then I unlock, and then I exit the thread. In the main part, I am creating three thread variables, and pthread mutex init lock. Okay, and looping three times. I have created threads, and then this, and then ptex mutex destroy and lock. Okay, so does it mean that when I initialize a lock, after that, whatever threads are being executed or created, if inside those threads I ever encounter lock and then unlock, uh, after encountering a lock, no other threads will be executed? Maybe, I don't know, but if that is the case, then I can just use a non-synchronous programming. I can just use synchronous program. Why use pthread lock? Without a mutex, multi-thread might modify counter at the same time, causing race conditions. Might change counter at the same time. Alright, so in this critical moment, yes, after lock, no thread will be executed. Okay, I can choose when to do it and when not to do it. Compilation is instruct compile with pthread flag. Uh, Nope, that wasn't required when I did my compilation. Creates new thread, pthread joins, pthread exit terminates a thread. That is not how I did. Okay, maybe this is how to exit a thread from inside the thread. Mutex lock, unlock, mutex destroy. Okay, now what is POSIX, 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 right? POSIX. What is POSIX thread? POSIX is a standard. POSIX, what is POSIX? POSIX is a POSIX thread. P-thread is a standard for multi-threading in Unix-like operating systems. It is defined by the POSIX Portable Operating System Interface. POSIX. POSIX, I've heard that. Portable Operating System Interface. Uh, this is the standard which provides a portable and standardized way to create and manage threads. To create and manage threads. Key features of POSIX threads: lightweight and efficient. Threads share the same process memory, making context switching faster than creating new threads, new processes. Concurrency and parallelism. Multiple threads can run concurrently, time sliced on a single core. Yep, can run concurrently, time sliced on a single core, or in parallel on multi-core CPUs. Thread synchronization provides mutex, condition variables, and semaphores to prevent race conditions. Race conditions when the same value is being accessed by two threads, so they have to race towards that to make it work right. Works across different Unix-like systems: Linux, macOS, BDS, Berkeley software distribution, and even on Windows via POSIX compatibility layers like Sigwin. These are the functions, POSIX key functions, and example of POSIX thread. Okay, since thread designing is a complex job, and therefore when people want to add multi-threading abilities to their programming languages. When people want to add multi-threading abilities to their programming languages instead of designing everything from scratch, instead of designing everything from the scratch, they can accept and follow a pre-defined design like POSIX, threads, which deals with the tedious work of designing a multi-threaded system, and the programmer can just focus on implementing that standard. Is that correct? Question mark. Yep. Yes, exactly. Instead of designing a multi-thread system from scratch, many programming languages and operating systems adopt POSIX threads. Adopt POSIX threads or similar well-designed threading models. This allows them to leverage a robust, well-tested standard rather than reinventing complex threading mechanisms. Why use a predefined threading standard like POSIX? Avoids complexity. Designing a thread system from scratch requires handling context switching, synchronization, scheduling, and resource sharing, which is extremely complex. POSIX threads provides a ready-made, efficient, and standardized solution. Portability across platforms. By following POSIX, code can run on multiple Unix-like systems. Example, these Linux, Mac OS, BDX, BSD, Berkeley software and distribution without major changes. By following POSIX, code can run on multiple Unix system. Code can run on multiple. I don't get it. Code can run on multiple Unix system, even Windows support. POSIX threading. Focus on implementation, not low-level details. Developers can focus on writing application logic without worrying about threads and are managed, how threads are managed at the OS level. The OS handles scheduling, execution, and termination according to POSIX standards. Standard API for multi-threading. POSIX threads provides a function, provide a set of functions like these, making multi-threading implementation consistent and predictable across different systems. Language binding for higher-level languages. Many languages wrap or abstract p-threads to provide higher-level multi-threading capabilities. For example, this Python threading module internally uses OS threading APIs on POSIX. Okay, what does it mean in Python? I can create a thread like that. That is cool. Start this thread and make it join back. Um, so is it like OpenGL, which is a standard? Wait, OpenGL provides a set of standard functions, uh, which okay. What does this mean? What is POSIX threads specifying exactly? And who is following that specification? So POSIX threads specify a standard which is implemented by operating systems and which are implementing by operating systems. The POSIX thread the POSIX thread standards defines a set of functions which the OS can provide to application level code to create and work with threads to create and work with threads. And these functions are provided as syscalls. These functions are provided as syscalls. Since this is a standard, then multiple since this is a standard, then multiple programs can be written. Shit. Then multiple programs can be written for an OS that adheres to the POSIX thread standard, in, expecting to have the POSIX functions available. Expecting to have the POSIX functions available, functions provided by the OS. I guess that is kind of right. Yep, that is exactly right. Okay, so POSIX is an definition of a standard API that is implemented by the operating system, allowing application programs to use multi-threading in a consistent and portable way. Why portable way? Because they know that their software, mm, the part of their software which handles multi-threading, if it works on Linux, that same standard can be used to work on Mac OS or on BDS or any Unix-like operating system which implements POSIX. Breaking it down step by step, POSIX defines a standard. POSIX Portable operating system interface specifies a set of functions for thread management, synchronization, and scheduling. These functions must be implemented by any OS that wants to be POSIX compliant. That is important. That wants to be POSIX compliant. Operating systems implement the standard. Unix like OSs, Linux, Mac OS, BDS, Berkeley software distribution implement these functions as part of their own system libraries. Implement these functions as part of their own system libraries like glibc, mosl, etc. and kernel level thread management. Windows does not have native support for pthread but can use compatibility layers like this are GW, SIG, Programs use these functions via syscalls. Application level code calls pthread functions like this and this, etc. These functions internally interact with the OS kernel, often making syscalls to create, manage, and synchronize threads. Portability across POSIX compliant systems. A program using POSIX thread function can run on any OS that implements pthreads without modification. For example, a C program using pthread create can run on both Linux and Mac OS without changing. POSIX thread API system call examples. Uh, while you use pthread create in user space, the OS handles the low-level thread creation through syscalls. Right here, here is a function. A function is created. A pthread is initialized, is declared. Here it is initialized, and here it is joined. What happens under the hood? Pthread create calls our internal system function like clone on Linux. The OS creates a new lightweight process LWP on kernel thread. The thread shares memory with the parent process but has its own program counter and registers. The OS schedules the thread and switches between it and other processes. POSIX thread function versus system call. This is this, this is this or this. Alright, on Linux, libc GNU C library GCC compiler GNU C compiler GNU's not Unix provides Richard Stallman provides pthread functions which in turn use syscalls provided by the Linux kernel. Alright, that makes sense. And then programming languages can create libraries that internally call these syscalls and provide a better interface, which is called abstract data types EDT, better interface for a programmer to work with those threads question mark. Yes, exactly. Yes, exactly. Programming languages build libraries that internally call POSIX thread functions, which in turn makes syscalls to provide a more user-friendly API for working with threads. How programming languages built on top of POSIX threads. POSIX threads are functions provided by the kernel, and they are in turn provided in the programming languages through libraries, and these libraries internally make syscalls to the kernel to make threads possible, but they provide a very user-friendly interface to dealing with those threads to the user. Most programming languages don't implement threading from scratch. Instead, they wrap the POSIX threading API. Yes, API, and fuck. All right. How is this different from OpenGL? In OpenGL, there is, of course, the OpenGL is similar. OpenGL, Vulkan, and CUDA. These are similar, and these are standards. All right. So, what are these? These are standards which define some APIs for specific functions, and then there can be drivers written which adhere to those specifications and implement those specifications and provide those exact defined APIs so that an application level program can just call those API and trust that the driver which has been implemented adhering to any of these standards like OpenGL, Vulkan, or CUDA will perform a specific task that is defined by the standard. They provide high-level abstractions instead of working directly with pthread, create, etc. Programming languages offer easier to use stuff. C++, I do not know C++, but it would be amazing to learn C++ so that I can abuse it later. These libraries hide low-level details like thread stack allocation, synchronization, and scheduling. Example, uh, pthread internally is called, here I call the thread function, and this is a function. Okay, so this is how I give input to a function in C++. Isn't this just overly complicated? Ah, okay, and here this is the main function, and here I have created std thread and internally uses pthread, and then here I join it. And in Python, it is just start and join, and this is the thread. And what is the thing that I have, the function that I have to do? It is this function. Okay, and in Rust we have something similar to C++. Alright, and C there is the pthreads library, syscalls like this and this, and this on syscall benefits. Okay, that makes a bit of sense. Pthread create. Okay, how much time has it been? It hasn't been 1 hour. And let me play Oppenheimer, Interstellar. It is not a ghost. It is not a ghost. It is science. Yep, Interstellar. Benefits of language specific. Yeah. Pthread create. This takes in a thread pointer. Creates a new thread. Thread routines. Yes, I want to know what these exactly mean. It takes in a thread constant, and it takes an attribute, a pointer, a constant pointer to pthread attribute, and then pointer to routine which returns a void pointer and void pointer to the arguments, right? And threads dot c. Let me give it a more complex structure. Struct uh, type def struct. This will be called. It will contain an integer which will be just number and char pointer. Nope. jar array. Let's say name 10 characters. This is called data, and in here this will take in a void pointer of arg, right? And let's say data pointer data equals data pointer for arg, right? Expected expression. What expression did you expected? Convert this thing into data pointer. This is a void pointer. This is a void pointer. So convert that into a data pointer. That should work. Type converting a pointer into another pointer. Right, that should work. This is exactly what I'm doing here. Convert this thing into a expected expression. What does it mean? Printf, and number is %d and name is %s. The new line, comma, number is data dot number, comma, data dot name, and remove this and return null. What is the expression that this expected? All right, this is confusing. Data with data. I will be called args. This will be called args, and this also will be called args, right? And here I have created two threads, right? I want to create multiple threads, let's say. So pthread pointer, no, not pointer, threads, let's say 10 threads. Pthread, did you mean pthread t? Yes, I did mean pthread t. And I will here define number of threads, which are a thread count. Count is 10 and 14 thread count, right? And here I will do for in I equals 0, I less than thread count I plus plus, and inside I want to find a memory some memory in the heap. No, I don't want some memory in the heap. I can initialize a new data structure and I will pass it, right? So data pointer args equals, I will keep it as a void pointer, malloc size of data, malloc, okay, I have to import malloc, right? After getting that, I can do args dot number is equals I, and args dot name, args dot name. How do I define the name? Args dot name equals, I cannot just do that. Args dot name bracket 0 equals, let's say a plus I, and args dot name bracket 1 equals b plus I, and args dot name bracket 2 equals null 0. And then create thread p thread create. First I have to give in the address for the thread, address of threads bracket I, right? First the address, then due to some reason null, and then the function that will be called the function that will be called is thread function. Do not call it right here. And then the argument that is to be given args. That does seem to work. That does seem to work. And copy that and paste it here. And no, I don't want to do this. But yep, at the end, before returning, I will do free args. Args or arg doesn't matter. And a semicolon, of course. 117 args. No, I am not doing a create this time. This time I'm doing p thread join and threads I with null due to some reason. Threads I. Did you mean threads? What did I say? Threads I, right? Join it, and join the threads, and that should be it. Let's see how does that work. Not slash out. That does work. Okay, since these are threads, so it is misbehaving. I got 0, 3, 1, 5, 2, 6, 7. These are, well, yep, working parallelly. Shit, how can I count how to find the time that a function took to execute in C? This would be great. Amazing. Clock. I can use clock. Okay, yep, and a war to end all wars. And what was the multics thing? Multics for to avoid race conditions, to avoid race conditions. The multics thing, it was, no, multics was the operating system created before Unix. Not created, but conceptualized before Unix. It was in here, yep, p multex t lock and counter. No. Okay, all right. Here I have a global variable which I do not want to be updated while I have updated before this and this statement. So therefore I have done a lock. But that is something that I have control over. But what I do not have control over is when this thing will be executed. Whether this thing will be executed before or after something else. Before, since there are multiple of these functions running, what I do not have control over is when these individual functions start running. I can stop the execution for another function when this one is running, but that doesn't mean I can choose their starting times. So, yep. So what this guarantees is that I'm not printing the same counter twice, but the order of those counter is something that I have no control over. That makes sense. That makes sense. Pthread multex t lock, and I can specify that threads starting and closing between these two should be locked in this context. I guess. P threads multex p threads. Okay, p. Okay, what the heck? P threads. P threads. Thread p thread multex mutex mute am I stupid? Mutex init? Nope. Mutex lock. Mutex. Okay, mutex t lock. Okay, I'm just declaring a variable. Mutex t called lock, and here before initializing the threads, I will do p thread mutex lock. And what is the thing that I want to lock? Lock the lock, and give the address for the lock, and then lock the lock. And at the end, I would like to p thread mutex unlock the lock. Hello cd lock. And inside the function rv, at the critical moment, I can do p thread mutex lock and unlock. Okay, and long p take okay, init and destroy. Mutex init and destroy. So p thread mutex lock what? Lock the lock. And at the end, before just exiting, unlock the lock. And here this should be p thread mutex init to few arguments. Okay, I guess it can be null. Yep, it can be null. And here p thread mutex destroy, and it will take lock, destroy the lock. And yep, that should not make any visible change in my program. Yep, it just works as it did. And yep, the order will change. Order can change. Order can change. Order can change because these are threads and I have no control over their execution. Now threads.c, if I were to define a counter, global count, and instead of here, this is very stupid. What does this even mean? Right, and just change this to only store a number. Wait, not even store a number. I don't need a number like that. Nope, I don't need that. I just call this with null, and in here I'll do count plus plus and no name, only a number, which is going to be number is going to be count. So in this way, I will not see the same number twice. That is my prediction, and I do not see the same number twice, and they are printed in order. Okay, because I'm accessing the same variable, so doesn't matter which thread is being executed when, it will not be changed during the execution. Yeah, that makes sense. And if I were to not do this and this and this and this and this, then I'll see overlapping between the threads. Yep, overlapping. And I did expect to see multiple numbers, same number being printed twice, but it is not. I expected some numbers to be skipped, but they are not. Okay, we can look into that. Why is that? And first of all, let me go to washroom before that, and I'll be right back. I'm back and I'll reduce the volume of the music for you guys. And you can hear me, which is fine. Yep, screen is working and everything seems fine. And yep, the lock. I expected to see numbers being repeated in the lock, but they are not. Mhm. Why did I expect to see numbers being repeated in the lock? Because I wait, yes, okay. In this code, my question is here. In this code, here, okay, not even here, just a basic concept about threads. In when a thread is created, it means that a piece of code is sent to the OS to be executed separately separately from the main function, right? Question mark. Yep, when a thread is created, a piece of code, usually a function, is sent to the OS, which schedules it for execution separately from the main function. However, it still runs within the same process and shares resources like memory, file descriptors, and global variables with the main threads. That is amazing. How thread creation works. Program requests thread creation. You call a create function. Example this. You pass in a function. OS allocates resources for the new thread. The OS allocates a new stack and registers and program counter for the new thread. It does not create a new process, so the new thread shares memory with the main thread. OS schedules the new thread for execution. The OS assigns the thread to a CPU core depending on the scheduler. It runs independently but can still communicate with the main thread. Of creating a thread in C, which is pretty normal. Explanation. Pthread create tells the OS to execute thread function separately from main. The OS schedules the thread and runs it on available CPU cores. Right? Pthread join ensures that the main thread waits for a new thread to complete. And which thread does it wait for? Whatever is provided in as the function input. Mhm. Mhm. All right, that makes sense. So when creating multiple threads, the main function can only tell the OS that it wants the OS to execute these given functions separately, but the actual execution is handled by the OS, and thus order can't be specified in any way by the main program. Uh, that means that it is not necessary uh, for the thread created that was created first to be that was created first to be joined to be to return first. That is managed by the OS. Is that correct? Yes, exactly. When program creates multiple threads, it only requests the OS to execute those threads separately. However, the actual execution is controlled by the OS scheduler. And one thing, yes, bit more sound, and maybe I should decrease it here. That much, I guess, would be fine if anyone is trying to listen to my voice. However, the actual execution order is controlled by the OS scheduler, which decides when each thread runs, on which computer core it runs, for how long it runs before switching. Because of this, the thread that was created first might not necessarily finish first. The OS may pause one thread and run another depending on system load, priority, and available resources. Like in this, I would love to see how C++ works and how Rust works. Possible outputs are different. Yep. Finishing. Why does it say finishing? Oh, it is when simulate work. When it is finished, it could be finishing in any order, right? Run one, run two. In run one, thread one starts, two starts, three starts, and they start in the exact order that they were created, which is not necessary. Yep. See, in the second one, they are not starting in that order, and they finish in any order. Key takeaways: execution order is not guaranteed. The OS schedules and joins ensure that the main function waits for all of these threads to complete. Now, what does the mutex function does? Mutex, it is mutex, right? I guess mutex, mutual execution, to avoid race conditions somehow. Mutual execution mutex is a synchronization mechanism that prevents multiple threads from accessing shared resources at the same time. It ensures that only one thread can enter a critical section, shared a part of the code that modifies shared data at a time. How mutex works. Lock. Pthread mutex lock. A thread locks the mutex before accessing shared data. Critical section. The thread safely modifies shared data. Unlock. Pthread mutex context. The pthread unlocks the mutex so that other threads can proceed. If another thread tries to lock the mutex while it is already locked, it will have to wait until the mutex is unlocked. Example: preventing race conditions with mutex. Yep, create mutex and do this lock critical section, and it is increasing it a bit, quite a bit, and that is changing the data and then working here. So while one thread is doing this, other thread cannot be doing something else with this. Okay, okay, and it created two threads and then joined two threads, and mutex destroyed. Mutex was initialized there. Without mutex, if we remove mutex and lock and unlock, both threads will modify shared data at the same time, leading to incorrect results. Expected shared result should be this. Actual output varies per run. Shared result is this random error due to race conditions. Why? Without mutex, correct context. While one is changing the shared data at a time, final output will always be this. Key points. Okay. Why would this thing happen? Why would this thing happen? Um, would this happen even? Oh, okay. Okay. I guess. I understand what it means. Okay, why would this happen? I suppose that while one thread is changing, okay. I suppose that let's let's say that before any thread is created, the shared resource is stored in some X state, and then two threads are created which access that data and change it. And let's say that the first that one thread is changing the data starting at the condition X, and while it is doing that, the next thread also starts to manipulate the data. But the problem is that this new thread starts to change data starting from the X state, starting from the X state. Starting from the X state, and not where the first thread ends its ends its date, where the first thread finishes data manipulate data changes. So when the time comes to store the changed data, the thread which finishes last will override the thread which finished first, and thus the data will only reflect one of the changes. Let's see, you are absolutely right. The scenario you are describing is a classic race condition. It occurs when two or more threads access shared data concurrently, and at least one of them modifies it. If there is no synchronization to control the access to the shared resource, it can lead to unexpected results threads are racing to update because the threads are racing to update the data, and their changes are inferred with each other. Okay. Wait. So, in this, my problem was that I didn't see one variable being printed twice because here I'm changing count. Yeah, so I should see it being changed. No. I should see it being changed. Wait. Let's make count a pointer, and here I'm not increasing count, but I'm increasing whatever is at count, right? And then here I'm doing go to count and do stuff with it. Should that work? I Suppose I should see same numbers multiple times or a segmentation fault. Go to count and do this. Why a segmentation fault? Count, go to count gets the address of 0. You cannot take the address of integer. Okay. A equals 0 and or if int a equals 0 and given the address of a. Yep, I guess that I don't think will work. 1 2 3 4 5 6 7 8 9 10. That is fucking. Why is it mostly in order? Why am I not seeing same number multiple times? Shared breakdown initial state. Let's say the shared state starts at some place x, and thread 1 begins modifying the data starting from x. Let's assume it is incrementing the value. Thread 2 starts while thread 1 is still modifying the data. This thread 2 starts as accessing shared variable from the same initial state x and modifies it, and data override. Since neither thread knows what the other is doing because they are running concurrently, both threads are working with the same initial value x and can override each other's changes when they write back to shared variable. In this case, thread 2 can override changes made by thread 1. Yep. Visualizing the race condition. Thread 1 reads shared value, let's say at 0. Thread 2 also reads shared value again. It is 0 because thread 1 hasn't written it back. Thread 1 increments value to 1 and writes it back to shared value. Thread 2 also increments it and writes it back. And as a result, even though both threads executed increment logic, the final result is still 1. Why does this happen? Both threads are simultaneously reading and writing the same shared resource without locking it to prevent other threads from modifying it at the same time. This causes race conditions where the final result depends on the non-deterministic order in which the threads execute, leading to lost update. How to fix this? Use mutex, mutual execution. Okay. All right. Mutex can be used to resolve race condition. Okay. And that is handled by OS. Everything in there is handled by OS, and these are specified by the pthread standard. So pthread standard, okay, POSIX thread standard, threads standard. Shit, it doesn't. POSIX has its own website specifying the standard. Open group, Fedora, POSIX. The POSIX threads pthread is a standard API for creating and defined by IEEE EEE standard. This, let's see. This, it was defined in pretty early. It was redefined in 2024. Let's see. This is the definition. Working group details. Status. Approved in 2019 and board approval. This published in 24. And what is the standard? I have to purchase that. Okay, because it is not like an RFC. It is up to me whether I want to read it or not. Okay. Portable operating system interface. POSIX. It is like trademark. Yep, trademark. It is like an architecture design, right? Like x86 or something. ASI architecture Shit, how can I forget this? Instruction set architecture. ISA, instruction set architecture. Yes. And okay, that makes sense. To We used mutex, that is mutual execution, to stop race conditions from happening. Mhm. So that multiple threads are not accessing the same data at the same time. All right. Mm-hmm. Okay. And okay, that makes sense. Therefore, okay, let's go through this. I can draw this. I know I can. Here, let's say I am creating threads, 2, 3, and 4. And what happens in this thread is that there is a counter C which is initially 0. It increases the counter C++, right? And then prints the counter normally, right? So let's say the first thread starts executing, or let's say I have delegated all of these threads to be executed by the OS, right? And at that point, let's say it is the third thread which starts executing first. When that happens, it sees that C is 0, and here I have a lock condition. Lock and unlock. Lock starts. So no other thread can access this variable while the third thread is accessing it. So let's say while it is C thread is being executed, and the second thread also starts executing in another core, and it tries to access that variable, but it sees that there is a lock condition, so it stops. And let's say fourth thread also comes, and it does a stop, and first also comes, and it is also stopped because it is locked. And third thread sees that counter is 0, so it makes C plus plus, making the counter equal to 1, and then prints the counter. So I will first get 1 printed on the screen. Then the third thread is terminated. Stroke red, or I say red, RGB, right? So FF 0000. Shouldn't this be like absolute red? Yep. So third thread has completed execution. Let's say any one of these thread comes forward and it sees that the C variable is now 1. So it also increases the C variable, which now becomes equal to 2, which now becomes equal to 2, and after that it prints that whatever it is, and during its execution it also locks it and then unlocks it afterwards. It makes it 2, and after its execution it is just gone. It is completed. Then whatever thread comes next, it sees that C is equal to 2. Then it does C plus plus, increases the C, it becomes 3, and it prints 3. Execution is done. It stops, and counter is now at 3. Then the last thread, whatever is the thread, it sees that C is equal to 3. It does C plus plus to increase the thread, and during its execution, the thread is logged, and afterwards it prints C and completes its execution, and I see 4. Therefore, everything is printed in order. Let's say there is no lock. Mhm. Mhm. let's say there is no lock. All right, and in second condition, second experiment, there is no lock. I have multiple threads. Thread number one, thread number two, thread three, and four. And let's say I have told the operating system to execute these, and everything is same except the lock and unlock conditions. What it does is increases the counter by one and then prints the counter variable. Let's say one of these thread goes and sees that the counter is 0 and it increases the counter and prints the counter to the screen, and let's say I see 1 on the screen. But let's say while it was doing that, another thread came and see that the counter is 0. So it does wait and also there is uh there is a time gap between increasing and printing, and the time gap between the time gap between these two, let's say, is capital T, and the time that it takes to actually just increase the variable is small t. Now there are a couple of possibilities that can happen. Let's say while one thread is executing, another thread starts its execution while this is going on, while increasing is going on, and while that is happening, therefore, the count variable is not updated. Therefore, there will be race condition and count variable will lose some updates. The same value will be updated twice, starting from the same initial value. Therefore, two values will repeat in that condition. And let's say if a thread starts execution in this middle when nothing is happening, and the thread due to some reason got off from the CPU running time because the CPU did something, the OS did something. And if that happens, then the thread gets the updated value because updation has been completed. Therefore, no updates will be lost because when the new thread comes, it gets the updated value and then it prints it. But let's say that it has updated the value, right? And at the same time, another thread also comes. And okay, so this thread made the value 0, right? And these two threads, let's say this one got it, and this one made it 1, and this one made it 2. And then this one printed whatever it had. Now, should this one then should print the latest value of it, right? Yeah, this one should print the latest value. So, but it does not. It prints whatever it made the increase to be, right? So therefore, I guess this time is pretty negligible. Therefore, and mostly I won't be facing race conditions when I'm using this like 10 threads, and the increasing operation is only this much. Is only this much. If the increasing operation is only one increasing by one, but okay, yes, and threads. What if I say that I am increasing it by quite a bit? this starts at 0, and here I am doing this and then printing that, right? Let's say I go through a loop for int I equals 0, I less than 1000, I plus plus, and do count plus plus with that. After printing all the threads, I will print count separately, percent d new line, comma, count. And now ideally count should be equal to 10,000 because every thread is increasing count by 1, by 1,000. But I guess it will not be equal to 10,000. Out. It is not equal to 10,000. Some overrides were overwritten. And see, this one should have been 1,000, but it is not 1,000. 1,001 is here. Okay, the 1,001 is there. Mm, 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 mm. Okay, okay, I have a few questions. When a thread updates a global variable like uh, global count plus plus, and and then after a while it does this uh, printf percent d comma global count, does it get the value for printing global count from the memory, from the memory does it get the value for printing global, does it get the latest value for printing global count from the memory, or just uses its own local copy of that variable which it reached after updating. When a thread creates updates a global variable like this and later prints it, the value it print depends on how the variable is stored and how memory is accessed. Here is a breakdown. Memory model threading. Global variable. A global variable is stored in the global format data segment of memory. Right. All threads in a program share the same memory location, meaning all threads are accessing and modifying the same memory location when they update the variable, right? When they are updating, they are getting it from the memory and updating it. Thread local memory. Each thread has its own local stack for function calls, but global variables are not thread local unless explicitly declared with thread local in C++ or similar constraints. What happens when a thread updates global variable? When a thread updates global variable, it increments the value of the global variable in the shared memory. If the thread is accessing global variable after it updates it, it will always fetch the latest value from memory, not from a local copy. This is because global variables are shared by all threads. So threads, okay, let's just make this simple again. And after updating, I do sleep. Sleep, make it a sleep. I want call to undeclared function sleep. I want sleep one. Uh, sleep, 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 and is standard which library contains sleep. Um, a man sleep suspend execution for an time interval. Which library contains sleep? Standard library. Yes, I have all of these. Standard library. Which library contains the sleep function in C? Standard UniSTD. Okay. Include UniSTD. Yeah, okay. Now sleep does work. And now I am expecting to see multiple values being printed. Same value being printed. Same value being printed more than once. So what was happening before is that since just incrementing a variable once it does not take that much, therefore race conditions were not being shown as apparently. And this is not about that. This is not about that. Nope, nope, nope. This is not about that. This is not about that. This is not about that. Okay, I want to simulate something. Let's say in threads dot c and int a equals 0, and this is a pointer, and this gets the address of a, right? And here I'm not increasing count. Here I'm initializing a new variable, uh, var equals whatever is at count, right? And now I have gotten the variable, and then I do var plus plus. That is, I have updated my copy of the variable, and after updating my copy of the variable, I print my copy. Yes, I print my copy as a var, and this is called my copy, and then I will store it. I'll say go to count and make it equal to var, and then print f global value is %d new line, comma global value is equal to whatever is at count. Let's see, 18, and print nothing. One 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 one. That makes sense. That makes sense. Everyone is getting started because all the threads start executing nearly the same time, and therefore they get the same value, that is 1, that is 0. They all start at the same value, that is 0, and they all update it from 0 to 1. But if I were to change this with let's say count, go to count plus plus and make, yeah, instead of var I will be doing this. I don't even need var. Okay. To adhere to what I was writing before, this I get a local copy, I increment it, and instead of doing this there, I do this there. And let's see, I expect to see some different results, and I do see some different results. Yeah, and yeah, so it is just race conditions and thread and stuff. For most of them, global variable has already, not for most, for all of them, global variable has already reached 10. Yep, and I am hungry. Okay, what do I want to do next? I know a bit about threads, and what else do I know about? What are the questions? Yes, I wanted to see how to measure time, and does it affect the performance? Of course, it does affect the performance, but let's see. How can I measure time? It was time. Yep, clock. This. There are three methods. Use clock, time from time.h. Here some function which does workload and clock t start and end. Then a double CPU time used, okay, and start clock end, and CPU time used equals convert into double end minus start and divide that by clocks per second. Clock t. All right. So CPU time used is CPU time used. Okay, so this gives me the clock number, how many clocks were at this point and how many clocks were at this point, and then clocks per second, and then divide it to get the CPU time used. Okay, that makes sense. Not server, threads.c. So let's say that my function is a bit of a bitch, and count starts at 0. It takes quite a bit of time to execute. No sleep, nothing. Um, Not even free RGB. I'll just do count, not count plus plus. I want to simulate a big workload. I listen 10,000 and I plus plus. Redo count plus plus, and then printf count percent d new line comma count, right, and let's make this 1 lakh, and here I am creating threads and doing stuff. Okay, after creating the threads, I want to, okay, let's include the clock thing. Clock, yep, t, yep, equals, not is equals, start and end, and uh, double, BLE double time use, right, and here I will do start equals clock, call the clock function, and after the execution and completion of all the threads, end equals clock, right, and then time used equals end minus start. I have the number of clocks and divide that by clocks per sec and convert that thing into a double. Convert the thing into a double, not like that, like a little bit like that. Result of integer division, port loss of possible loss of precision. No, it is fine. It is fine. Possible loss of precision, and printf time used is music is gone, but I want to hear the music. Can you hear the music? Yep, I can. And then here given time used, but since it is double, so yep, long double. Time used, format specifies is long, but it says argument has a time double. Long, long. Uh, long. Invalid conversion is specifier. Double. Digit. Long. DD. Long. Format specifies long, but the thing that is provided is double. And double precision is different from long. Double precision is different from long. Result of integer division. Integer. Okay, how are they managing it? If float, okay, and convert end minus start into a double and then divide it. Okay, convert end minus start into a double and then convert it, and here use a float. Okay, time dot h, time dot h. Yep. Important, and yeah, this much time, this much, about 0.01 in all of them. And if I were to do it differently, using not using threads, but wait, okay, not using threads, but calling this function itself about 10 times or so, since it is already defined there. Let me comment all of this and do for int I equals 0, I less than thread count I plus plus, and call the function, which is thread function, and yep, given null. Let's see. Now it takes a smaller. I guess it is because the number is not too big, and just creating the threads and merging them together is taking more time. This is a million, this is a billion, so I would like it to be a long, long number, long float. How do I print long? LD, long, okay, long digit, clang and slash out. Let's see. Okay, it is taking time. Yes, since billion, a lot of billions. Okay, that was just once. That is going to take time and threads. Let me reduce 1 0, and let's see. It should be much faster. Right, and it takes about 4 seconds. But if I were to not do that and use threads instead, let's see. Or slash out. Fucking hell. That took no, that didn't took 13 seconds. That was much faster than 13 seconds. That took 8 seconds. That is not how I expected it to be, since it is running on maybe just the process of joining and spreading threads is messing stuff up. Let me add one more 0. Not slash out when there are quite a bit of threads and stuff. Okay, I expect to for them to be printed kind of simultaneously, and when the first one starts to print, I expect all of them to print almost simultaneously. Okay, these are running in parallel, so while one is executing, other is also executing, and they are going through the process of incrementing the global variable. Mm, uh, mhm. That took about 138 seconds. And if I were to do it in normal programming, says, shit, is it doing time sharing instead of running it on different cores? If it is doing time sharing, then this is not as good as you would want it to be. Dot slash out. Yep. How to see if threads are running on time machine sharing or on different cores. That one took 138 seconds, and I guess this is going to take much longer. To determine if threads are running on the time sharing context, switching between a single thread and a single core, or on different cores, you can use operating system tools like PS or HTOP on Linux. ChatGPT. How can I specify that I want to run a thread on a completely different core and not in time sharing context? How can I specify that? How to set up how to set up CPU affinity? This took 43 seconds. So multiple threads are taking longer. This took this seems like it took much longer than 43 seconds. Wait, maybe it is because of the way that it is counting time. Okay. Uh, so in this, when it is doing this addition, it is I don't know. It maybe could have taken 43 seconds. That makes a bit of sense. But that seems about right. But that one before it didn't take 138 seconds. That is for sure. And when I was testing it for another variable, another time, in here it said first it said it 13 and then it said 8 due to some reason. Mhm. Does creating a creating threads and distributing the workload increase the time used? Okay, I am calculating time in context. I'm not actually calculating time. I am calculating CPUs per cycle and using that to calculate times. Is that might be the problem? Yep. I'm calculating the CPU clock cycles and then dividing it by how many clock cycles are in 1 second. Get time of day. That seems much better option. Start, end, and travel time. Okay, they are a travel time structure, right? Start and then end, and then seconds. Seconds is along, and double is lapsed seconds. End dot TV seconds. End dot start dot time seconds here, and elapsed and microseconds is this dot usec, unisec, and unisec. Okay, that is microseconds, and elapsed is seconds plus microseconds. Microseconds multiplied by 10 to the power minus 6. Okay. And they are in the sys time library. That seems seems like that should work. What is this? Clock get time function starts. This gets a monotonic steady timestamp. We compute elapsed time in nanosecond and convert it to seconds. Function starts, function ends. Let me implement this clock. Um, which which time measuring which time measuring method is best to calculate how fast a function works when it is spread through multiple threads. When measuring the performance of a multi-thread program, so that might be getting too loud. It might actually be getting too loud, and this is about my battery is about to go out. When measuring the performance of multi-threaded program, particularly if our function is spread across multiple threads, it is important to account for the parallel execution and potential overheads, such as synchronization. Yes, that is the overhead. Overheads are taking time. Synchronization, thread creation, and context switching, that is taking most of the time. The method of time measurement should reflect the overall execution time for the entire set of threads rather than just the time taken by individual threads. Here are the best approach. Use get time. hmm And okay, and that is fine. And that I guess is the end of the stream. And maybe in tomorrow's stream or maybe today itself, I will offline I will add threads to our server so that multiple connection can exist at the same time.